My dear students, welcome to today's online class. In the previous class, we discussed on one-dimensional array, right? So today we are going to discuss next topic, that is two-dimensional array. Two-dimensional array. In the last year, we already discussed regarding a one-dimensional array and a two-dimensional array, right? What is the meaning by two-dimensional array? An array with the two subscript is considered as two-dimensional array, right? So we already know definition of two-dimensional array, how to enter elements into the two-dimensional array, how to write elements from the two-dimensional array. We already written some programs on a two-dimensional array, right? That is the addition of matrices, multiplication of matrices, transpose of matrices, right? In the first year. So this year, let us see topic on a two-dimensional array is representation of two-dimensional array in memory. It means how two-dimensional array is going to be represented in computer's memory. Regarding this, we are going to discuss in this class, right? So let us see. Let A be a two-dimensional array, has m rows and n columns. The array will be represented in memory by a block of m into n sequential memory locations. The array A may be stored in memory in one of the following methods. Means what he says, how to represent a two-dimensional array means a two-dimensional array is going to be represented in the memory in two ways. First one is row measure representation, and the second one is column measure representation. Row measure representation and column measure representation means now we are studying how to represent two-dimensional array in memory. How elements means array has elements. How two-dimensional array elements are going to be stored in memory. He says that to store a two-dimensional array in memory, it is done in two ways. First one is row measure representation. Second one is column measure representation. These are the two methods used to store two-dimensional array elements in the memory, right? And what he says, let A be a two-dimensional array with m rows and n columns, right? Two-dimensional array means what? An array with the two subscript is considered as two-dimensional array. Therefore, two subscripts are there. Therefore, those two subscripts represents what? Row number and column of the element. Means for a two-dimensional array, we need two subscripts. Each subscript represents row number as well as column number of the array. That's why he says, let us consider an array A with the two subscripts in such a way that first subscript represents row of the array and the second subscript represents column of the array. And row is indicated by, let us consider, m indicates number of rows in the array, n indicates number of columns in the array. Then two-dimensional array can be represented in two ways. First one is row measure representation and the second one is column measure representation. Then what is mean by row measure representation? Row measure representation is nothing but storing array elements in the row wise. Storing elements in the row wise. For example, let us consider an array A of 2, 3. Let us consider a two-dimensional array, that is int A of 2, 3. It means A is a array of int type. A is a array of int type with 2 rows, 3 columns, and this row is indicated by letter M and this column is indicated by letter N. Then how to represent it in a row measure representation? How to represent it in a row measure representation means, row measure representation is nothing but array elements are going to be stored in row wise. Means first row is going to be, first entered elements are going to occupy the first row. After occupying the first row memory locations, second row elements are going to be occupied to the memory location. That is, row wise filling is done when we are going to use row measure representation. For example, A of 2, 3, it means an array with 2 rows, 3 columns, means total elements of the array is row into column, that is 6 elements are going to be stored. For example, A of 2, 3 means A of 2 rows, right? So array element started with location 0, right? So here 2-dimensional array means 2 subscript. First one is A of 0, 0. Second one is first row is right. So this is what 2-dimensional array for this order. 2 into 3, 6 element. 1, 2, 3, 4, 5, 6 element. Suppose row measure representation means what? According to this order of matrix, 6 elements are going to be stored in array A. Row measure representation means we are entering 6 elements, right? For example, 1, 2, 3, 4, 5, 6. So how these elements are going to be filled means, suppose array representation is in row manner means, entered array elements are going to be filled in this way. First entered 3 elements are going to be filled in this way, 1, 2, 3. Again remaining 3 elements are going to be occupy the second row position, that is 4, 5, 6. It means first entered element 1 is going to be stored in A of 0, 0. Second entered element is going to be stored in A of 0, 1. Third entered element is going to be stored in A of 0, 2 memory location. After filling first row, once again array elements are going to be stored in the second row. Second row position is, first position is A of 1, 0. Second is A of 1, 1. Third A of 1, 2. Suppose array is a 3 cross 3 means next third row elements are going to be filled. It is very simple. Row measure representation is nothing but entered elements are going to be stored in a row wise. Entered elements are going to be stored in a row wise memory location. This is called row measure representation. Let us see here once again, row measure representation. In this representation, the first row of the array occupies first set of memory locations. What he says, in this representation, the first row of array occupies first set of memory locations. Here first set of memory locations means 0, 0, 0, 1, 0, 2. These are the first set of memory locations. Means in the row measure order, first row is going to be filled with the first entered element. Afterwards, second row in the second row memory locations, remaining elements are going to be stored. That is 4, 5, 6 is going to be stored in the second row memory locations. So in the row major representation, the first row of the array occupies the first set of memory locations reserved for the array. The second row occupies the next set, and so on. In array, that is in array, elements are stored in a row wise, one after the other. For example, let us consider an array A of 2, 3. It means total 2 into 3, 6 elements are going to be stored in this array, right? So here row major order means row wise elements are going to be stored. So row major order means first A of 0, 0, first row elements means these 3, right? So A of 0, 1, A of 0, 2. So this is what? First row. So this is what? First row. First row elements are stored in the array first. First row elements are stored in the array first. Right? So these are the first row memory locations. So these 3 are filled first, and afterwards first row completed, right? So it takes a second row memory allocations, that is 1 0 1 1 1 2, that is 1 0 1 1 1 2, A of 1 1 0, A of 1 1, A of 1 2, A of 1 2. Second row elements are stored, right? Second row elements are stored in the array after the first row. Second row elements are stored after the first row, right? Second row elements are stored after the first row. First row in the row major order means first row memory locations are filled with entered element. Afterwards these are what? Second row memory locations. Second row memory locations are going to be filled. In this way we can represent row major representation of two-dimensional array, right? Now let us consider column major representation. Column major representation. Obviously, what is mean by column major representation? After studying row major representation, we can easily say what is mean by column major representation. Means column major representation means in this type of memory representation, first column memory locations are filled with first column. In the first column memory locations, first entered elements are going to be stored. After fulfilling the first column memory locations, in the second column memory locations, after entered elements are going to be stored. It is very simple. Column major representation means entered elements are going to be stored in a column wise, right? Entered elements are going to be stored in a column wise memory locations. That is very easy, right? Now let us see example. See, in this column major representation, first column of the array occupies the first set of memory locations reserved for the array, and second column occupies the next set, and so on. For example, you consider the same example, int A of 2 3, that is the 2 rows 3 column, 2 rows array declaration end with semicolon, right? So 2 rows, 3 column. Then how to represent column on major representation means, so this is actually memory allocations, right, for this order. So column wise filling means first column is filled. For the first column on memory locations, first entered elements are going to be stored. That is a of 0 0, a of 1 0, a of 1 0, right? So this is first column, this is second column, this is third column. So here 3 columns are there. So therefore first column, consider first column means a of 0 0, a of 1 0, a of 1 0, right? So this is what first column, first column elements are stored in the array. So this memory locations represent what? First column. So first entered 2 elements are going to stored here, a of 0 0, a of 1 0. And suppose we are entering further elements means they are going to be stored in the second column. So what are the second column memory locations? A of 0 1 1 and a of 1 1, a of 1 1. So these represents what? A of 0 1 and a of 1 1. These represent what? Second column, second column. And third column means what? A of 0 2, a of 1 2, right? So I am writing here a of 0 2, a of 1 2 1 2. So this represent what? Third column, third column, right? Suppose 6 int a of 2 3 means this 2-dimensional array has capacity to store 6 elements. So I am entering 6 elements, 1 2 3 4 5 6. So how these elements are going to be stored when we are representing it using column measure order means, see here, column wise elements are going to be stored means first column means 0 0 1 0. So first entered element 1 and 2, 1 is going to be stored in 0 0, 2 is going to be stored in 1 0, right? So first column is over. Next for the second column 2 memory locations are allocated means for the second column these 2 elements are comes means a of 0 1 3 is going to be stored, a of 1 1 4 is going to be stored, 4 is going to be stored. And for third column 0 2 1 2 are the memory locations. So remaining elements means 5 and 6. This 5 is going to be stored in a of 0 2 and 6 is going to be stored in a of 1 2, right? O of 1 2. It is very simple. Row measure order means elements are going to be stored in row wise. Column measure order means elements are going to be stored in column wise, right? So this is what, how to represent a 2-dimensional array in memory. So 2-dimensional array can be represented in memory in 2 ways. First one is column measure representation and second one is row. First one is the row measure representation, second one is column measure representation. Now let us see the next topic, that is formula to find the size of 2-dimensional array, right? formula to find the size of two-dimensional array. Already we discussed it in the first year, right? Just recall, what is the formula? Size of two-dimensional array is equal to size of two-dimensional array is equal to what? Number of rows into columns. Number of columns, right? Number of rows into number of columns. For example, let A be a array of size 4, 5. Let A be a array of 4 size. Let A be a two-dimensional array of 4 size, means 4 rows and 5 columns. Then what is the size of the array? Size of A array is equal to what? Number of rows into number of column. The first subscript represent 2 rows, second subscript represent column. That is 4 into 5 is equal to 20. 20 is the size of two-dimensional array. Means 4 rows, 5 columns means this two-dimensional array has the capacity to store 20 elements in it. That is 4 rows and 5 columns are filled totally. This two-dimensional array has the capacity to store 20 elements, right? Next, let us see next topic, formula to find address of an element in the two-dimensional array, right? Formula to find the address of an element in the two-dimensional array. Let us consider on two-dimensional array, and after declaring two-dimensional array, where that element is going to be stored, what is the address of that element means. So it is possible to find address of an element in a two-dimensional array in 2 ways. That is in row major order representation as well as column major order representation. So for this we have 2 formulas. That is first one, row major order. Suppose array, two-dimensional array is going to be filled with row major order, means here we have one formula, that is location of A of ij is equal to base address plus w into n into I plus j, right? This is the formula. And for column major, order also it is possible to find address of location of particular element. That is, for column major we have another formula, that is location of A of ij is equal to base address plus w into m into j plus I. I, j plus I. Here what is mean by this where base of address means, where base of ADD means base address, and this W represent what? W represent number of words अथवा memory block, member of block, and m comma n represent what? Row comma column, row comma column, and this I comma j represent what? Subscripts. For example, this represents which element address we have to find, that subscript, that is I comma j represent what? Subscripts to find address of the location. Now let us see one example on both row measure order as well as column measure order. Let us see here. See here, let us consider an array. A of 3, 5, means it represents m and it represents n, right? Number of rows and number of columns. Find the address of A of 2, 3. Find the address of A of 2, 3 means in this array declaration A of 2, 3 means second row, third element, right? So we have to find address of this location A of 2, 3 we have to find. And what are the given data here? Given data is base address is 1. Base address is equal to 1 and word memory block is also is equal to 1. Then we have to find address of this address of A of 2, 3 means this A of 2 indicates what? Subscript I, and this 3 indicate what? Subscript j. In row measure order. So like this he is going to give data. With the help of this data we have to find address of this memory location. So he says row measure order. Row measure order means we have to consider this formula. Right? This formula. So what is the which address we have to find? A of 2, 3. Therefore location of address is location of A of 2, 3 is equal to base address. Base address means here 1, right? Base address plus w. W means here 1. So therefore bracket of n into, n means what here? 5. n into I plus j. I plus j means 2 plus 3, right? So what is the answer? Simplify it. 1 plus 1 into bracket of so here multiplication comes first. 10, 10 plus 3, 13. So what is the answer? 1 into 13, 13 plus 14 is the address. 14 is the address, right? So base address is 1. The address of 2, 3 means 14 is the base address. Means in the 14th is the address of this 2, 3 location. So like this we have to find the address of memory locations. So to find the address of memory location, we need base address, we need W value, that is a memory block value, and anyhow row and column numbers are given, and I and j is also given. So everything is given means, so this is the address, this is the answer. Similarly, let us consider one example on column measure order. This is first one. Second one, column measure order. Column, second one is column measure order. So here also column measure order. So here also consider an array. Let A of 3, 5 is an array. So A of 3, 5 means this represent what? M, and this 5 represent what? N. And here also base address is equal to 1. Base address is equal to number of blocks is equal to 1. Then we have to find what? Address of 2, 3. Same here, address of 2, 3 we have to find. Address of 2, 3 we have to find is equal to how much? Then see here, formula, we have to consider this formula, right? So location of ij means, location of A of ij means 2, 3 is equal to, what is the formula? Base address. Base address means 1 plus w. W means 1 into bracket nega. This is column measure, right? So take first row. What is the row number here? Row number is 3 into j plus I. J plus I means here 3 plus 2. 3 plus 2. So what is the answer? 1 plus 1 into, so 3 3 ja 9. 9 plus 2, 11, right? So answer is, final answer is 11 plus 1, 12 is the answer. So therefore A of 2, 3 is equal to, location of A of 2, 3 is equal to 12 is the answer. 12 is the answer, right? So like this we have to find address of an element in a two-dimensional array, right? So next is, let us see the advantages of this array as well as disadvantages of array concept. So in the advantage, what we can observe, it is used to represent multiple data items of same type by using single name. This is the advantage, right? With the help of array, we can store number of elements with the single name. Suppose we have to declare 10 variables means we have to enter 10 elements means we have to declare 10 variable. Suppose all the elements of the same type means with the help of single name it is possible to store all the 10 elements, right? So this is the first advantages. What is the first advantages? It is used to represent multiple data items of same type by using single name. This is the first advantages. And second one, it can be used to implement other data structures like strings, stack, queues, linked list. Right? In the first year, to represent string means we are using array concept. In the declaration we are using a of array size, right? So to with the help of this array concept it is possible to implement other data structures such as string, stack, queues and linked list. So in the last year we studied string concept, right? In the next class we are going to discuss stack, queue and linked list concept. So to implement such stack, queues and linked list, we are going to use array concept. So and a two-dimensional array are used to represent matrices. Also it is possible, we discussed programs also on matrices, right, in the last year. So with the help of a two-dimensional array concept it is possible to implement matrices concept. So these three are the advantages of arrays. Now let us see the disadvantages of arrays. We must know in advance that how many elements are to be stored in the array. This is the first disadvantage we can identify, because in the array declaration we are going to mention the size of the array. It may be one-dimensional array or a two-dimensional array. We are going to mention the size of the array in the array declaration. So this is the disadvantages, because we must know in advance that how many elements are to be stored in the array. Suppose we are not mentioning the array size in the declaration means it is not working. So we have to know in advance how many elements are going to be filled in the array. This is the first disadvantages. And the second one, array is a static structure, means it is a constant. It means that array is a fixed size. The memory which is allocated to array cannot be increased or decreased. Means in the array declaration itself we are going to mention the size of the array. That's why that is a constant. He says that array is a static structure, means it is a constant. It means array is of fixed size. The memory which is allocated to array cannot be increased or cannot be decreased. This is the second disadvantages. And the third one is the elements of the array stored in a consecutive memory locations. So insertion and deletions are very difficult and time consuming. Means in the array after declaration of array we are going to enter array elements. So those array elements are going to be stored in a consecutive memory locations. Means they are going to stored one after the other in a sequential manner. So due to this consecutive memory locations, what happens? Suppose we have to insert an element or a delete element from the array, means this operation is going to be very difficult. So these are the advantages and disadvantages of array. In the next class we are going to discuss a new topic, very interesting topic, that is stack. Thank you, students.